Hello and welcome to Advent of Code Day 12. Getting ready for next problem to become available for us here. About 30 seconds left to go. Yesterday we had a pretty strong performance, finishing in the top 50 for both stars. Let's try to keep that streak alive tonight. But really, it's just going to depend on the problem. I think I should remove my input from yesterday, so that I know exactly where it's going to be on the file system if I save it. All right. Here we go. All right. Memory banks, village, communication, pipes, messages are passed. Most of these messages aren't reaching. Some of the pipes are missing. Okay. Door to door like a traveling salesman. Okay. That contain, all right, so this is, they're asking basically what is like the transitive closure of this set of programs. Okay, so we can parse this thing. So let's say something like this should be good here. Okay, and then our parse function P is going to take source, something that we don't care about, and dests, and we want to emit something like a mapping, maybe like for D in map dot replace in this thing, replace the commas that we don't care about. I'm noticing a problem with the way that we're reading this in here, which is okay. So so slurping it is good. I think we just need to do something like dot split this on here. Okay, and then that seems fine. Or actually, we could probably just modify this program here, take out this else to always just return input here. So just modify this like this, and okay. All right, so this is a lot better. Okay, all right, and then so replace this in each of the here. Okay, that looks good. And then let's see. So we want to emit source to dest here, and say something like map P to here, and maybe into something maybe like apply merge with concat. If it's like something, actually this shouldn't be necessary here. So we should actually just be able to emit source and this part here. Okay, as long as no sources are repeated, which does seem to be the case in this input. All right, so here we do map P, and then we basically want to we do some kind of loop where like we have like the frontier, which consists of just 0, and like a set containing 0 here, and reachable is also going to be like the set containing 0. And then for each of these steps here, we're basically going to recur, where the so I think the reachables is kind of easier. So that's basically just set union. Which do I have here? Closure.setUnion. Yep. Okay. So we basically want to take the closure set union of some function here, solve, where this is the map M here, of the reachables with let's see, I think we want to apply to something like map the map M to the frontier here, and then maybe something like let the new frontier be, so this actually sounds good. Okay, like this. Something like that. But then we have to do a closure set difference between what we've already reached and these new ones here. Okay. So here's the new frontier. So we want to recur like that. All right, and then the reachables are going to be everything from the new frontier, and then we want to say if there are still things that we haven't reached yet, then recur. But if there are things that we haven't reached, we want to basically just return the count of reach, something like this. And then we solve here. Map P, okay, okay. A lazy seek can't be passed to a function. All right, and that's because this needs to be a map. Okay, can't find replace for a character. Okay, let's take a look here. So what's the first one of these things? So this is saying that you're going to receive a thing that, I see this should be and tests that. All right, now it's saying can't find a method replace for, oh, right, replace it with the empty string here. Okay. Okay, count is not supported on characters. Well, it seems like we're calling count here, but it does seem like reach is gonna be, does seem like reach is gonna be, well, so let's, I don't know, get the first of these and just take a look at what we got. So, okay, what about the last of these? Okay, both of these look good. What is the issue here? If I just ended up returning reach from this and just said def s, okay, so it can't get there. So it's doing some kind of, all right, so something is doing a count. This could be, this part here. So this should be fine. This part should also be fine. What happens if I do a map cat of this thing to the set containing the string 0? Does this work? The answer is yes. So far, so good. All right, then so I should, I guess the question is whether set union supports, can I say set union 3 things here? Looks like that's fine too. Okay, recur on the new front and then this part. So seems like something is asking for a count of something. If so, this should be fine. All right, let's see if we can get the stack trace here. All right, so this says it looks like it's doing max key. Why is it doing max key? Because it's doing something bubble max key. When we're doing union, apply set union to, okay, oh, I think I see, this shouldn't be applied, this should just be set union. Yeah, okay. Okay, and then so let's do this. Oh, this is taking a while here. Surprising. Only got 2,000 elements in it. Yeah, that's pretty surprising. So let's maybe mark this frontier here. Let's start another REPL. Redefine this thing, call our same solve, and then basically say what's the count of the frontier. Oh right, we're calling it f. What's the count of f? So it says 1, 1, 1, 1. All right, so this is, it's like, it's saying the things that are in here that aren't in here. Okay, so the new frontier is, so this is defined wrong. This needs to be this, and then this set difference here. Or is it? No, no, the set of things to look for are the things, oh, right, this is wrong. Yeah. This needs to be like that. Okay, so stop you, redo this, try this again. Count of S, 134. Right answer, rank 280. All right, next part of the problem. There are more programs than just the ones, okay? No way of reaching, how many groups are there in total? Okay, yeah, that's a pretty good problem. Let's see, what are the best ways of doing that? So I think what we can do is we can change our solve to maybe solve with M and K, and we can change what it returns. Yeah, so it's just going to return the reaches, and then we basically want to say, something like loop for K in the keys of. Okay, so we're gonna let M be this thing for each. Okay, so so how do we need to do this? So we're going to start with like our inputs, which is kind of like the set of keys, and then when we do a recur step, we're going to do a set difference from everything that is reachable. So all right, so something like let K be the first of inputs here. If K, then, all right, and then we also need like an N, starting like at 0. So if K, then we'll do our recursion step here, doing a set difference of solve M on K, and then incrementing N. And then otherwise just return the N like this. All right, mismatched counts to recur. Don't see the problem right. Oh, right, yeah, this actually should be right. So this N needs to go up here, and then the let like this. All right, wrong number, pass to solve. There we go. Okay. Seems to be taking too long, right? Because I'm calling set difference in the wrong way. So we got to call take the inputs, take out what's accessible. Still surprising. Huh. So start with inputs. We're in a recursion step. So we're starting with a set of things. Is it possible that so it is returning the reachable set. I mean, we could do something like this. Try to see. Okay, so The problem seems to be, is set difference not working? Why not? Is it returning? Do I need to do this? I shouldn't. It should already be a set. Inputs is this. We'll get the first thing out of inputs. My guess is that K isn't changing. Why would K not be changing? We take the closure, we take the set. Okay, turn the set of this. Yeah, no good. No good. What is the problem here? Let K be the first two inputs. Okay, this is in the recursion step. Recur starting here. Starting out like this. So my guess is that somehow this set of things is just not the same thing as set of things here is just not the same as the set of things being returned here, and I'm not sure why that is. Okay, actually, so we actually should have something about the frontier. So this is a set, okay, and then what are the keys of this? This looks fine. Like this, no, like this here. This is just gonna keep giving me the, oh, no. Yeah, this is just, the problem is that it's, inputs isn't changing. All right, well, def II inputs, def RR for the reachables to be this. Okay, take this off. Okay, run this. Stop and let's take a look at RR. What? Ah, here we go. Okay. I mean, this seems to be just normal set. And then if I inputs, okay, what happens if I take the closure set difference of II and RR? What's the count of this? The count II. Okay, what's the count of RR? 134. What? How? It's telling me that there's nothing in RR that's also in II. What? Okay. This has all the numbers. And this has some of these same numbers. It has, or does it? Okay, I guess, maybe it is doing somehow the right thing. Okay, I see what the problem is. The problem is that I have to include, no? Oh, yeah, I see what it is. Yeah, I've got to do it. Yup, that's it. Okay. 193. All right, right answer. Rank 372. Okay, so not too terribly, but not any points today either. All right, we are well. Tomorrow we'll be officially more than halfway through Advent. Very exciting. Our Advent calendar is filling up. Very, very beautiful. Getting everybody in the season. Let's talk about the problem a little bit. So what we have here is basically a definition of a graph with edges that are not directed, and the Yeah, actually, so something that I didn't take advantage of, but it looks like wasn't required, is that it actually tells us that, so my guess is that if I go to 889, then it'll actually have our 0 in there. Okay, so fortunately for me, both sides of the edge are represented in our inputs. And then the first question is how many of these inputs are reachable from here, and our algorithm in that case is that you basically start with so you start with two things. You have the set of things that are reachable, and then you have like a frontier, which is the set of nodes that you haven't already explored. So your reachables and your frontier both start at your starting point, and then your new frontier becomes the set of things that are reachable from your current frontier that you haven't already reached. And then you just recur. You just continue on with your loop until it gets to the point where you don't have a frontier anymore. And then, so yeah, very, very straightforward algorithm. And then in part 2, the question was how many different subgraphs are there where none of the nodes, so like in subgraph A, for example, none of the nodes can reach anything that's in subgraph B. So yeah, I think they provide like a couple examples there. And in that situation, yeah, it's another pretty straightforward algorithm where it's actually kind of like a nested application of the same algorithm, because in the outer case here, you also have sort of like a frontier to explore. In this case, your frontier is the set of all the keys in the map, and then you just have to watch as you take each step to remove the keys that you've already seen. Yeah, so pretty straightforward. I got caught up for a while because my front and reach sets here were initially hard-coded to start at 0, and that sort of gave me the this weird sort of infinite loop, which wasn't actually quite. So the problem is that what it looks like is that this set difference isn't doing anything, but then when I examined the behavior of the program, I saw that it was doing a little bit. So like I saw that all of these nodes were being removed from this set of sort of all the nodes that I need to explore. For example, this is 0, which is where I started, isn't present in this frontier set. But once it gets to that point, then there's really nowhere to go, because you keep like this solve function just kept starting over at 0, which wasn't even the set of things that we were looking for anymore. So yeah, this is the stuff that little bugs are made out of. Like I said, no points today, but tomorrow is a new day, and we'll try again. So that wraps it up. Thank you for watching, and hope to see you tomorrow.